In this lecture segment, we'll talk about the selection of desktop or laptop computing environments versus a cluster computing environment, specifically with respect to storage, the storage limitations that come with our desktop computing, and the storage capabilities that come with a large-scale distributed file system that we'd find in a cluster environment. So most of us are familiar with the desktop or laptop computing environment. We've come accustomed to the response time, how quickly we would expect our laptop to boot up. With the advent of solid state drives, we expect that to now be almost instantaneous, instant on. And we've come to understand the amount of time it takes to load a file into our particular applications, whether that be MATLAB or Mathematica or an R or Python script, whatever our particular scientific applications are for our domain. We've also come accustomed to moving files on and off of our desktop or laptops. If we were to download files, whether that be gigabytes worth of movies or whether that be gigabytes or terabytes worth of research data, we've come to expect what that takes in a desktop environment to move data on and off. We've also come to understand moving data in terms of thumb drives, external drives, how we write data onto or off of those particular drives and share data. Now, when we're talking about sharing data externally, that moves back into the remote distributed file systems, whether that's cloud such as Google Drive, or whether that's moving data with FTP and other devices that we've talked about. So why would we ever need to leave the desktop environment? It's wonderful, right? We love our desktop environments, but ultimately there are limitations to sharing data, the scale of the data, and tying that data to compute resources, right? So maybe you've only got 100 gigabytes of data and it fits perfectly on your laptop. However, you need to do lots of different post-processing of that data, and your laptop does not have enough compute power. So we may need to move that data into a distributed file system that can leverage the cluster computing resources. Additionally, maybe we have large files that won't fit onto our laptop or desktop, so we need to leverage larger capacity, right? So if we have terabytes, that may not fit onto a laptop SSD, right? So this all brings us to start thinking about when should we think about a distributed file system or a cluster-based file system. Now, such file systems bring a significant amount of complexity, but they also bring a significant amount of capacity and compute capability benefits that we may need to leverage for our data-intensive scientific computing. All right, cost is important because when you're trying to scale out your research, you need to understand the cost of the resources that you're going to require. Fortunately, in a desktop environment, most of those costs are the lowest relative to other storage options. And a lot of that comes to the manufacturing at scale of individual consumers. And we talk about those aggregate consumers, whether we're talking hundreds of millions or billions around the world. So the vendors and the manufacturers have a lot of motivation to manufacture large quantities of these at the lowest price possible. Typically, there's actually a small number of manufacturers in terms of specific hard drives, but there's a large number of vendors such that you can go to your favorite online IT retailers, whether that be a Tiger Direct, a Newegg, an Amazon, or you can buy external hard drives in most of your traditional shopping venues here in the US, like a Target or a Walmart, a Meijer, something like that. And if we're talking storage in terms of thumb drives, or even some external hard drives, sometimes you can now find those in the checkout aisle at your grocery store or at your drugstore. So let's talk about the capabilities. When manufacturers are making these and when they're being marketed, what are consumers interested in? And consumers typically purchase based on the raw specs, and the primary spec there is capacity. If they're looking at an external hard drive, they want to understand if they're talking in hundreds of gigabytes or if they're talking in terabytes. They're talking thumb drives. They're trying to understand if this is 16 gig or 32 or 64, 128, or they're trying to understand the maximum capacity they're going to get. If they take another look for the next metric, that's typically speed. And hard drives are different than thumb drives, and typically folks go, hey, the biggest number is the best number. If this is rated at an 8 or a 10 or a 7200 or a 15,000, all of these numbers fly around. But typically consumers will just buy the largest number in the speed category once they've already made their capacity choice. And then finally, and rarely do they ever look at the operational robustness, and that's, can this device run 24/7 under a heavy load, which is important to enterprise, but consumers very rarely do this. And why is this important? Well, this is what the manufacturers are going to make and market to the consumers. They're going to market the highest capacity. They're going to put some sort of large number that makes the speed look attractive to consumers, and very rarely will they build in operational robustness. They really want to maximize capacity and come up with some respectable speed number. Last, what they're looking at on the consumer device for your laptop or your desktop is it's going to have minimal installation and operational complexity. They want to target the majority of consumers that can buy this at their store, bring it home, and plug it into their laptop with a USB connection, maybe for advanced folks, maybe a eSATA connection or one of the special like Thunderbolt connections. Typically, they're going to be external devices for the majority of consumers, something they can just plug in. Occasionally, there'll be internal devices for the enthusiasts that will crack open the case on their desktop and add an additional drive. Or they might be, even more often than putting in an internal drive, they'll buy a NAS or network attached storage device that they can plug in and share with their family. Or maybe they just need larger capacity with some level of RAID redundancy, and they can get that with a network attached storage appliance that they'll buy for their home use. So let's compare and contrast remote distributed storage or distributed file systems that you would typically find in an enterprise class commercial system or a large research cluster. Now, some users are typically surprised to see that the costs are typically higher per terabyte. The concept is, hey, I can buy a terabyte online, a USB drive for a certain price. Why does it cost more? In the data center, you're buying lots of additional hard drives, more hard drives than I am. But it's important for the user to understand simply buying a hard drive, in a chassis with a USB connection so you can plug an external drive into your laptop, is significantly less complex than the terabytes that are presented to a user through a distributed file system. All of those hard drives go into servers, and then those hard drives typically have some level of data redundancy, whether that be through RAID, which utilizes parity, or whether that be for full copies of the file so that if a drive fails, there's other copies of the files that have been replicated. So with that level of redundancy and the additional servers for which the drives need to be plugged into, total aggregate cost of hardware and software typically makes that a higher cost per terabyte than you're going to see just buying a drive online or at your local consumer store. So let's talk then about some of the capabilities. And again, we mentioned before that in the enterprise market, that 24/7 operations comes into play. The drives are typically designed and manufactured to a higher level of quality such that we get lower failures. But in addition, we do have that parity, or we have RAID, or we have the redundant copies, such that that file system provided to a user has a lower likelihood of having data loss or data failure. In addition, when you have these large sets, we design both for capacity, such that you can continue to expand. On your laptop, it would be hard to expand to hundreds of terabytes kind of linearly. And then we also have speed considerations. So if we have lots and lots of hard drives running simultaneously, we can provide much better speed to your aggregate compute than if your individual laptop was trying to access all of these hard drives. Your laptop would not be able to keep up. Finally, in the capabilities, understanding sharing and security is important. So if you have data and it's only local on your laptop, then you're going to need to either let people log into your laptop to access that data, or you're going to be moving it around with external drives or thumb drives, that sort of thing, unless you share it out over the network, which again is now in a distributed file system. And then with sharing comes security. You need to make sure that the right people are accessing that data at the right time. Last, as we might expect, the complexity of distributed file systems and enterprise class file systems is significantly higher. As we've talked about, now we've got lots of servers, which involves lots of hardware. So first you have to deploy the hardware and get it properly configured in the disk drives in those individual servers. And then once you have all of those servers configured, you're going to layer on top of that a distributed file system that aggregates all of those servers and all of those disks into hopefully what looks to the user like a uniform shared namespace, a uniform file system, so that the user can run jobs across many different nodes, utilizing all of those compute resources and access all of those different files as if they were mounted uniformly across all the nodes in one particular file space. This is typically going to take systems engineers who have an expertise in those particular file systems in that particular hardware so that they can then present those to the user level. Hopefully, the user doesn't have to understand how to deploy any of these things, but it's important for the user to understand what is underneath the hood in as much so that they understand where bottlenecks occur, why the price points aren't where they thought they were, so that they can leverage greater capacity, greater sharing, greater performance, and maybe not necessarily be surprised by some of those bottlenecks that come into play that they don't experience when they're using their last laptop or their desktop.